everyone, and Merry Christmas. Welcome to my session for the festive tech calendar. In this session, we're going to have a look at how you can give the gift of infrastructure as code by taking your Bicep code and wrapping them up as modules. Modules are a really useful feature of Bicep that takes some of the more complex features of ARM templates and makes them a lot easier to consume, and lets you take all your hard work and wrap it up and redistribute it to whoever needs to take advantage of it. So let's have a look. Let's dive into how you can use modules to make yours and other people's lives a little bit easier. Okay, so to get started, let's have a look at what modules are and why you'd want to use them. At their core, modules are just normal Bicep code that you put in a separate file. Sounds pretty simple, but that is really all they are. Under the hood, as you probably know, all Bicep code compiles into ARM templates. Under the hood, modules turn into nested ARM templates, which literally are ARM templates calling ARM templates. So if you actually look at an ARM template generated by Bicep where you have a lot of modules, they actually become quite complicated. There's quite a lot of code under there, but we don't need to care about that because all we're interested in is the Bicep part. The ARM bit is just what happens under the hood. So a module is some logic that you put into a separate file that you can then call from another Bicep template. And there's some more complexities to that when we get into how you distribute modules and give them to users, but ultimately that's what it is, the way to call one file in Bicep from another and run the code in it. Now you can already see off the bat the benefits of that, because you can obviously call that file multiple times. And then if we get into sort of the complexity of adding parameters and stuff, you can make it more generic and so on. And we can do a lot of work with a single separate file that's going to be consumed by another one to make it really useful. And that's what we'll have a look at in a minute. So we know what they are. They're just Bicep code in another file. Why would we want to use them? So I'm calling out a few high-level benefits of using modules here. Obviously, there are probably more than that, particularly when you're looking at your particular situation, but these are some of the really common ones. The first one is probably the most obvious. You can use Bicep modules to share code. You can put the code that you're interested in sharing with other people, other teams, into a separate file, and you can give that to another person to be able to use and that can be as simple as a few lines of Bicep to really complicated hundreds of lines of Bicep code that you're going to share with another user. And you can do things, like I said, you can add parameters, you can add outputs to those to make them reusable, to make them more generic, so that you can take the logic that you've invented and allow users to customize it by what they pass in or out of the module. Another benefit of this is around avoiding repetition. So if you are running the same Bicep code multiple times, obviously probably with different input parameters, otherwise you'd get the same result every time. But if you were running it multiple times, you are writing that Bicep code over and over again. So if you extract that into a separate file and you then just call that same file multiple times, then you're only writing that Bicep code once. If you need to make changes, you only need to make those changes in one place, and they're reflected in every part of your code that calls that separate module. And so it avoids you having lots of repetitive code that can be really painful when you get into large projects. Another great reason for using modules is to add some sort of standardization or some sort of compliance to your code. So maybe your company's got a certain way that you must deploy storage accounts. So let's take an example. Your storage accounts must use standard storage. You don't allow premium storage. You want to enforce that HTTPS is always on, and you want to make sure that the storage firewall is always on and it's not exposed directly to the internet. Obviously, you can have your users informed about that and give them a policy or something that makes sure that they have to do that when they write their code. But what you could also do is just create a Bicep module for your storage account, and instead of calling the normal built-in storage account resource, you call the company name storage account, and you pass in a few values, and it automatically sets up those standards. So it automatically picks the standard storage. You don't have to give it a storage property. You don't have to give it a storage SKU option because that's already selected for you. It turns on the firewall and maybe automatically populates it with your company's IP ranges for you, so you don't have to do that. Turns on HTTPS, all those sort of things. So you can do the work once to create a compliant storage account and then deliver that module and have everybody use that module, and they'll get a compliant storage account without having to put much effort. Another benefit you can do with modules, and these the last two here are less about working with other people, and naturally these are a benefit of modules even if it's just you working on your project. So you can write a Bicep project and you can have a single Bicep file that has all of your logic in it. But if you're deploying a lot of resources, that can get really unwieldy. If you've got lots and lots of code in there, it can be quite difficult to find the specific thing you're looking for and so on. So you can use modules just to break up your code. So you can have lots of subfiles or submodules that have got individual bits of your resources. Maybe you've got a network module and you've got a storage module or something like that that are then called by a top level template. You don't necessarily need to worry about distributing those or making them available to anybody else. They're just part of your project, but they mean that it's easier for you to reference where you want to be in the code. If somebody else comes along and wants to work on your project, you could point them at the particular file so they don't have to learn the whole set of your code. It can just make it easier to read and consume. And then secondly, the last one there on the compartmentalize is quite similar, but you can also break your project up into specific types of resources. So maybe you've got a team that are working on a deployment and you've got some network specialists and then you've got some compute specialists and so on. And so you can break that up. You can have a network Bicep file that's worked on by the networking team. You can have a compute one that's worked on by the compute team, and then bring them all together into your top level template. Again, those modules can just exist within the same project. You're not distributing them to anybody else, but they help you break up your code so that different teams can work on them much easier. So some high level benefits there of what modularization of your code with Bicep can bring you. Let's take a look now at how they actually work. How do you write a module and what does the code look like? And then after that, we'll have a look about some of the best practices. So how do you actually write a good module? So let's hop over into VS Code and we'll have a look at that. Okay, so here we are in VS Code and we've got a module that I've written previously here. If anyone's done my Bicep for Real course, you'll notice this is actually the module we create in that course. So it might be familiar to some of you. If you are wanting to dig more into Bicep, I would recommend go have a look at that course. But this is a module we've created and it's a module for doing private endpoints. So if you've ever worked with private endpoints in Bicep, there are a number of components that we need to create. So when you create a private endpoint, you need a private DNS zone to do the DNS parts. You need a network link for that private DNS zone. You need the private endpoint itself. And then you need the private endpoint link to the DNS as well. So 4 different components. And you can see that the code, there's a fair amount of actual Bicep code here. So by extracting this out into a module, we are doing a couple of things. Firstly, we are making this less complex. So somebody who wants to create a private endpoint doesn't need to write all this code now. They can just write a little bit of code to call this module. We're standardizing, so we're setting up the private endpoints in a way that we like. And we're making it much easier for somebody who isn't familiar with private endpoints and just has been told, okay, you've deployed a storage account, you need to put a private endpoint on it. It's making it much easier for them to be able to do that. Now you will notice that in VS Code here, this Bicep code is just plain old Bicep code. There is nothing in this file that is special about it being a module. Where some sort of special module code comes in is when we actually try and consume the module, and I'll show you that in a minute. But the code that is in this module file is just plain old Bicep that is just creating those resources. So we've got some parameters coming in, we've got some resources we're creating, and then we've got some outputs at the end. So you don't need to do anything special in terms of writing the code, but obviously you do need to think about what your module looks like, and particularly what the interface of your module looks like, which in the world of Bicep is basically your parameters and your outputs. How are people going to interact with your module when they run it? And we'll talk a bit more about that when we look at best practices, but you need to think about when you're writing this, okay, what am I going to ask the user to provide? What information do I need them to send in when they use the module? Versus which information am I going to hard code or make assumptions about that are on my side. So you can see here on the private DNS network link, I'm allowing the user to customize the name, but some things like the registration enabled is turned to false. So I'm not using these DNS zones for VM registration, so I've just turned that off, and that's not a choice I allowed the user to. Whereas things like the name and the network ID is something that they can provide input. Then I'm just creating the actual resources. Again, that's just plain old Bicep, so I just need to figure out what resources I want to create in here, what parameters I'm feeding into those. And then at the end, we've got the outputs. So you've got to remember when you're creating modules, somebody is going to be consuming your module as part of a wider or larger Bicep file. And so it's very likely that they are going to need to take some values that were created in your module and use them elsewhere. There's no way for them to do that and grab those from your module unless you put them in outputs. So the output is the outgoing interface for your module, and so you need to make sure that you are providing the information from your module that they might then use later on. So for example, for my private endpoint, I'm passing the ID of the private endpoint we've created, and that's a really common one. You'll find in most modules that you pass some IDs of the resources that were created because you're going to want to reference those later. And if you've got the ID, then you can go and then do an existing lookup for the record and get most of the other properties if you really need to. But we're also adding some other information. So we're actually, as well as the private endpoint ID, we're also passing out the DNS zone ID that we created in case they want to use that DNS zone later. They want to add some more records to it and so on. So this is my module. It's pretty simple. It's got some inputs, it's got some outputs, and then it's got some resources it creates. And I've just saved that. And at the moment, this module is just sitting in a module subfolder. And so really at this point, this module can only be consumed by this particular project. We'll look at how you can distribute those modules to be easier to consume later, but at the moment it's just within this module subfolder. So if we go to our main biceps, this is our top level bicep file that's actually doing the rest of the resource creation. And we're doing some basic stuff. We're creating a VNet. We're creating a storage account, and then we are using that module. So you can see the difference here. For the storage account, it's a resource, whereas for the storage account private endpoint, it's a module. That's a different keyword. And then instead of the actual API version, what we're passing in is the path to the module. So the module subfolder and then private endpoint.bicep. And that's the kind of special module syntax that you need to be aware of. That's how you say, go and use this module. We give it a name, and this is just a name for the actual module in Bicep. It doesn't actually get reflected in what gets deployed to Azure, because as far as Azure is concerned, there is no real such thing as a module. It's just some code to deploy resources. And the parameters section basically lets you put in whatever parameters that we requested in the actual module itself, so they can match up. You see there. All of these parameters are mandatory because we haven't set any default values. So if we wanted optional parameters, we could just come in and do, let's call that West Europe for a location as the default. And so that would allow us to make that optional. So if somebody didn't specify the location, we would default to West Europe. So we fill in the parameters, and that's pretty much it. So you can see here, this code is 10 lines of code. It's much simpler than what was defined in here with these 63 lines of code. So we're making that simpler, but also where value then comes in is we're also creating a key vault here, and we want a private endpoint for a key vault. So we're going to go ahead and call the same module. Because we've parameterized it to allow us to change this, we've changed it from the blob resource type down to the vault resource type, and we're passing a different DNS zone and a different resource ID. So we've parameterized it enough to make it generic, but we can now reuse that. So we've now, when we did the first one, we saved ourselves 20 lines of code, but now we've saved ourselves another 60 lines of code because we've reused that logic again. And if we needed to go and make some changes to that module to make it more useful. So for example, at the moment, this private endpoint one allows you to specify the DNS zone to create, but it always creates a new DNS zone. If you're creating a private endpoint for a resource type that you've already got another private endpoint for, then at the minute you can't use this module because it will try and create a new one. It'll probably fail because it already exists. So if we want to fix that problem and we want to allow this to go and use an existing DNS network, so DNS zone if it exists, we can make the change once in this module file, and then all of our resources that use this module will get that update. So that makes it really simple to do those updates as well. We've also compartmentalized our private endpoint logic in here. So if we had a network team that were looking after private endpoints, they could just manage that file and not deal with the rest of it. So you can see right off the bat, we've got quite a few benefits of modularizing that private endpoint code rather than repeating it over and over again in this top level file. Okay, so let's have a look at some best practices for when you create modules. First one, and probably one of the most important ones, is make sure that your module actually has value and there is a point to it. When you create a module, there needs to be a reason why you're extracting it out into its own file. Now, if you're doing some of the stuff we talked about where this is really for your own benefit to break up files and compartmentalize, that's slightly different. But if you're talking about a module that you're going to deliver to other people to use, there needs to be a valid reason for them to do it. It needs to do more than just create the resource that's inside it, if that makes sense. If you create a module that creates a resource group, and inside the module it just goes and creates a resource group, then why would anyone want to use your module over just using the normal resource group option inside of Bicep? So for example, if you create a module for creating a storage account, there needs to be a reason for somebody to use that module above and beyond just using the normal storage account resource. So if you have a module that just takes all of the inputs for storage account and passes them on and creates a storage account, then there's no value there because it's not doing anything different than the standard resource. But in the example we talked about, where the module does some work behind the scenes where it adds the company IP ranges into the firewall, or it enables HTTPS, it's making some decisions for the user, or it's providing some benefit to the user so they don't have to go and look up all those IP addresses, then there is benefit into doing that module. But if it's just replicating what the Bicep code and what Azure already does, then there's no point to it. So make sure that your module does something useful so that the end user will actually use it. Next up, we saw that you create the interface for your module through the inputs and the output parameters. So you need to think about this up front. You can change the logic in your module whenever you want, really, in terms of what it's doing when creating the resources. But if you change the parameters going in or out, this affects the users who are consuming it. If you add a new parameter that's mandatory and you publish a new version of your module, then that will break the end user's experience because they now have to pass in this new variable. Now, we can combat that a little bit with versioning through module repositories, which we'll look at in a moment, or making them optional parameters, but you need to consider that carefully and make sure, ideally, that your interface is pretty fixed once you release it. So you think about that up front and consider what the user is going to want to pass in and what the user is going to want to get out of the module. It's easier to add more outputs later because they're just additional things that come out of the module. But even then, if you've missed one and somebody's consuming your module and they say, no, we haven't got this particular output, you're going to have to go back and make that change. So ideally, if you can do it up front, that is much better. Next up, you need to think about your modules and do your modularization at the right level. It can be tempting to think, okay, we've got a specific problem with this particular project and we need to deploy an Azure web app with a SQL server and a front door in front of it. So why not create a module that does that? And you absolutely can. And if that's a common sort of use case that you are going to be doing, then that's great. But if somebody then comes along and says, I really liked your module, but I only need a web app, I don't need the other pieces. How can I use your module and not get those other pieces? You can't really. You're going to have to either go in and amend your module to add some sort of flags to say, do I want the SQL server, yes or no? Or you're going to have to break up your module later to only have 3 modules that do each one of those different parts. You're doing better off up front breaking it down originally and having a web app module and a SQL module and a front door module and allowing those to be deployed in the same project and maybe having values and making sure the output from the web app module has some useful information that can be passed to the front door module and so on. Now, again, it's going to come down to your own use cases. If that scenario where you're deploying those 3 things is something you do a lot, or you've got a specific use case, then absolutely do that. But think about what the right level of your modules are and build them at that level as needed. And you can, if you want, have modules calling modules. It makes things a bit more complicated in terms of seeing what's going on, especially if you ever look at the ARM template code, which I wouldn't recommend. But you can do that if you want to, but it depends how complicated you want to get. Consider who's going to own the module. So if you're lumping a load of resources together, as I mentioned before, if you're sticking in, let's say, a virtual machine and a VNet in a module, are you potentially going to have different teams dealing with those later who want to perhaps make their own updates? Have you got a network team and a compute team who are going to be fighting over the module? Are you better off breaking them into 2 separate modules that can be managed separately by those teams if needed? And then the last one, and this is a really important one to actually get people to continue using your modules, is to keep them updated. Make sure that if there are new resources or new properties for whatever you're modularizing, you do update them to get the new properties into your module. Getting people to use your modules can be tough, particularly if they've already got code that does certain things and maybe it isn't compliant with your corporate policies and you want them to use the modules. You've got to evangelize them and get them to use those. And there's nothing worse than if you've got them sort of some progress, but then they need a new property and it's not in your module and your module doesn't get updated very often, so they just go back to using the standard resources and they're back out of compliance again. Really try and keep them updated with new options. One thing you can do is have an Azure DevOps board or a GitHub issues list or something where people can raise requests about your modules, so you can track them, maybe even have a release schedule. All those sort of things can be done if you want to try and make sure that people are using them and are happy with your module. Okay, so those are just some of the best practices. I'm sure there are many more, and if anyone's got any that I want to highlight, please do add them as comments to the video. But now let's go have a look at actually creating a module, and we'll go through the process so that you can see how that is done. Okay, so we're back in VS Code, and we're going to create a new module, and we're going to create a module for the storage account. Like we talked about before, we want to force some standards on our storage account. So first up, we want to make sure that the SKU is only using standards. So we can see that this template we've created here is already not in compliance with our standard because we don't want them to use premium. We also want to enforce HTTP actually on by default, but we want to enforce it in the code so that no one can actually turn it off. And we want to add the storage firewall to make sure that there's some corporate IP ranges in our firewall. So let's go create a module file, and we're going to call it storage.bicep. And we are going to first off start creating our interface. So there are some parameters we know we're going to need. So we need a location. Okay, fine. We also going to need a name for the storage account. Add that in. So let's start with that. We're going to add some more later, but we'll see how that goes. So next up, we know we're going to need to create a storage account. So let's go ahead and create the storage account. We know that the name is going to be the storage account name properties. The location is going to be that. We want to enforce storage read D2, and we want to enforce standard LRS. We can do that, but then we've got an issue here. What if they want standard GRS? We do allow that. So what we can do with that, we'll add a parameter, and we'll call it storage account SKU, and we will use that here. Put the string in there. Okay, so that'll work. But if we do that, then we're back at the original place where somebody can just pass in the storage account SKU as being premium. So to resolve that, what we need to do is look at some allowed value list. Okay, so we want to define what values can be passed to that. So to do that, we add a decorator to that parameter. So we want an allowed values list, and that's going to be an array. And the values in here are going to be standard, let's go LRS, and standard, GRS. So we will allow those ones. Don't need a comma there, sorry. Okay, and what we'll also do over here is we will add a default so that it's not mandatory, and we will make the default standard LRS. So you can see we're making our interface a bit more useful here. So we're not just allowing any old things, we are passing in an allowed list, and we're making a default to make the end user's life easier. So if they don't know, if they come along, I want a storage account, I don't understand Azure storage accounts, I don't know what these things mean, they can just not provide this and they'll get a standard LRS account right off the bat. So that's going to do the SKU. What we also need now is some additional properties. So we want to enforce HTTPS. So we're going to say that. And we're going to say support station traffic only. And then we want to add the network ACLs to restrict this to traffic only from our corporate IPs or obviously from private endpoints. I'll just paste this in because it's a fair amount of code here. So let's just see how to look at this. So we're setting an ACL, we're allowing Azure services in, we're setting the default action to deny, and we're adding some IP rules for allowed access. Obviously, I've just made up the IPs there, but you can see the principle. So we've got that set up now to allow those IPs. We've got HTTPS storage enforced here, and we are forcing standard LRS or standard GRS. So let's quickly save that, and we'll go back to our main template. And what we're going to do is replace this resource. So I will just add it in first, and then we can replace it. So we've got a module here. We're going to call it storage account 1 as well. It'll complain for a minute about that already existing, but that's fine. And we're going to call that module that's in that file, and we are going to give it a name, which is just the name for the module. So we'll give it the same name. Go. And then we need the param section where we provide those values. The location is coming from the value that was passed into the template. The storage account name is going to be storage account 1. Probably won't actually work when you deploy it because it's already used, but I don't care for now. And then the SKU, and we're going to say it, and you see nicely IntelliSense here already picks all this up for us. So we are going to say standard GRS, and that is it. So now we can get rid of that resource, and now we've got that using the module instead of that resource, and it will pre-configure all of those. So that will work nicely. But one other thing I wanted to call out here was around the IP ranges. So you saw here we were putting these IP ranges into this IP rules list, and that will work fine. But obviously the things like corporate IP ranges are quite a common set of data that might be used in lots of different places and lots of different modules. There's probably quite a lot of sort of configuration data that's unique to your company, but that is used all over the place. So one of the modules I quite often create is a config module. So let's go ahead and do that, and I'll show you how that works. So a config module doesn't actually create any resources. What it does is it contains your company-specific data that you want to distribute still. So this allows you to wrap it in the module, give it to users, and they can consume this and get these values without having to know them themselves. But it's all in one place. And this is mainly done by having a module that's mostly filled with outputs. So let's create one here called corporate IP ranges. It's going to be an array, and then we're going to give it a value, and we're going to take those values from over here, at the top. Okay, and that's an output, so that's available for use. And you can basically fill this config with lots of different information about your corporate environment. So one of the things we've seen a lot of is naming conventions. You can add those in here. IP ranges is obviously a common one. Group IDs, if you add things to resources that have permissions for certain groups, they can be in here. Rails to services, all sorts of things you can add in this corporate range. You can also sometimes benefit of using parameters. So particularly for naming conventions, that's quite a useful one. So if you add a parameter here for, let's say, call that a string. So let's say you got a naming convention for resources, and one of the things it uses is the region of the resource, or you're doing the deployment in to create the naming convention. So we'll go here and we'll create an output here called name prefix, and it's going to be a string. And let's just go really simple, and we will say, okay, the naming prefix is going to have the company name, for example, of Lambda Toys, which we use in the other courses, so we'll do that. And then we want to also append the region to the naming convention. So we will use that there. And that will then give that as a value that you can then consume in your name of the resources. And you can be as complex as you want in that. There are some things you need to do. So this won't work for a storage account because of the hyphen, and it's probably too long as well. So you might need to get a bit more complicated in terms of how you generate those. Some of mine also have like resource specific naming conventions. You might want to add an indicator what resource type it is, all that sort of thing. But you can be as complicated or not as you want to be in the config module. So now we've got that, let's look at consuming that. So you could call this module directly from other modules. That will work, but the way I like to do it to make it a bit simpler is actually you create the module in your top level template. So we will create this module here called config, and it's in the config.bicep, and that's it. It doesn't have any properties, so we just need to give it a name. We'll call it config, and we do have parameters because we had that region name, so we're just going to use that. We're not actually using it, but let's add that in, and we'll say that's going to be Europe. This is just a string at the end of the day, so we can call it whatever we want. So we've got the config module, and what I would then do is either use this config module in the passing to the resource or pass specific properties to the resource. So you're going to want to add a parameter to the actual resource. So we've got our storage account. We'll go to the parameter section, and there's a couple of ways you can do it. So you could pass the whole config module through and use that. So you can add a parameter, you call it config, and it will be of type object. That's what will get passed through, and then you can consume that. Alternatively, we could just pass the IP ranges through, and that will be an array because that's what we set up in there, and we could just pass that individual through. So if we do that, and then we go back up here, and we're going to say, okay, so for the storage account, sorry, the main one, we are going to pass in IP ranges, and they are going to be config.outputs.corporate IP ranges, and that will pass that through. So we now need to consume that. Obviously, we've got an array of IP ranges here. This is not an array. It is an array, but it's not an array of IP ranges. It's an array of these objects here. So we need to do a little bit of conversion. So what we can do is we can create a variable to structure those values the way we need them. So we're going to create a variable called IPs, and we basically, what we need to do is loop through the IP ranges array and then construct that JSON object. So we can use the for option in Bicep, and we say for IP in IP ranges, and then a colon, and then do that. And what we need to is create that object. So we just say value is that IP value, and the action is allow. We've missed an equal sign there. Okay, and that should do that for us. So then we need to do is replace this. Now the output of this is going to be an array, the array of objects, which is what we want. So we can replace this whole array with that. In a case issue. There we go. It said the wrong case in there, so we were able to fix that. Yeah, so that will then basically consume that property and then reconstruct it into the sort of arrangement that we need for this. Now, we could have just in our config module, we could have just made this output to be exactly what was needed for the storage account. But the problem then is that that's designed for storage accounts. And if we want to then use the same thing to add a firewall to a SQL server, we'd have to reformat that again. And it's going to be trickier to reformat from that type of object than just an array of IPs. Now, if you wanted to, we could create some, so we can have an output here for storage account IPs. And we could make that specific to the type the storage account wanted to. It's up to you how complex you want to get on that. But yeah, that's a config module, and I find that's really useful, especially if you have a lot of sort of configuration data that you're going to be using all over the place, or that's managed from a central location. IP ranges are a great one because there's always new corporate IP ranges coming along. If you can just update them in one place and they get then consumed by everybody who's using them, that saves you an awful lot of. Okay, so that's our module done. We're going to use that for the storage account, and that will create that storage account in compliance with our standards and without anyone having to rewrite that code and so on. So the last thing we're going to have a quick look at is how we can deliver those modules to people so that they can consume them more easily. Okay, so last thing we're going to have a look at is how can we distribute these modules. So at the moment, these modules really are only available to this particular project. They're stored within the folder structure, and there's a local path to it. If you want to get these to other people, there are a few ways you can do it. Obviously, you can just zip up this modules folder and send it to someone and they can unzip it into their project. That will work absolutely fine. You could take it a little step further and maybe commit your modules to a Git repo and have a Git repo that people can check out and clone into their projects, maybe even use a sub-module to do that. But to be honest, the easiest way is to use a module repository. So Microsoft have released recently the functionality that you can store your Bicep modules within a repository in Azure, and then you can consume them from there from any project. So making it much easier to get those out to people who want to use them. So the module repository is just an Azure container registry. It uses this thing called OCI artifacts, which allow you to store pretty much anything in a container registry. And in the case of this, we're going to go ahead and store our Bicep modules in there. So there's two things we need to do. First, we need to upload the module, and then we need to consume. So over in Azure, we've got a container registry here called Bicep Reg, which is set up to store the modules. And if we have a look in repositories, there's already a module in there for the private endpoint one. We're going to add our storage one, and then we're going to consume that within our code. Okay, so to publish, we need to do it from the command line. There is a PowerShell command, or there's an Azure CLI command. We're going to use the Azure CLI command, and it's a pretty simple one. So AZ Bicep publish, and basically you give it the name of the file you want to publish, and then you give it a target. And the target is basically a path in the registry. But there's a couple of things you need to have. So the first thing is you need to prefix it with this. Let me zoom in a bit. You need to prefix it with this BR option, which basically just indicates it's a bicep file. It's just a sort of prefix that's used on all of them within this container registry. Then the name of your registry, so the full name to the container registry, and then a folder path. You don't have to use this path. I'm just using it here. So just bicep files, then modules, and then the name of the module, and then you give it a version. So not only does the module repository allow you to sort of distribute your modules, but it also allows you to version your modules. So people can consume a particular version, and when there's a new version out, they have to consciously move to the new version rather than it being forced upon them. So you can deal with breaking changes like we talked about for that as well. So we'll go ahead and publish, and that takes a minute just to upload the file and push it into the registry. And what we should see now, if we hop back to the Azure portal and refresh, we should have our storage module here, and we do. And you can see we've got the V1 module here, and you can see a little bit of information about it. You can't actually see the code that's in your module here. You would have to download it to look at that, but you can see it's been published. So that's now in our registry. What we need to do now is actually consume it from our code. So in our Bicep code, all we need to do to consume it is to change this path to stop pointing to a modules path, or a local path, sorry, and have it point to the Bicep registry. And all we need to do is delete this and then paste in the path to the registry the same path we use to upload the file to. You'll notice here at the end mine is changed to V2. So when we uploaded it was a V1. I found an issue that I'd actually previously had a different version of the V1 one and it cached it locally. So my storage account was showing some errors here. So I just pushed the V2 version and that's picked that up and it's not giving me any errors anymore. It just shows you how you can version those modules so that if you make some changes, you can push a V2 and anyone who's still on V1 will still work and they won't have to do anything until they decide to switch to V2 and make any changes that are needed. But now I've changed that. That will work. When I come to deploy my Bicep code now, it will pull that module down from the registry. I can get rid of this modules folder that's pointing locally because I'm not using it, and they will get pulled from the server. The config module is still pointing locally because I haven't uploaded that, so I will probably go and upload that one as well. And obviously at this point, you could then go and add some automation into your module. So you could have maybe a pipeline that runs off your Git repo where you store your modules that pushes new versions when they're created, all that sort of stuff. You could go to town on it if you wanted to, but at the moment, this works great. This will just pull it from the module repository and my code will just work. And that's pretty much it. You should now be able to take your Bicep code, wrap it up, and give the gift of pre-created infrastructure as code to your team so they can just reuse all the hard work you've done rather than having to do it themselves. I hope that was useful. I hope you enjoyed the session and hopefully you'll check out all of the other festive tech calendar sessions and hopefully you have a great Christmas. Merry Christmas.